Okay, we have a short little lesson video today with respect to congruent polygons. So the word congruent, which we've seen a few times already this unit, congruent means the same size, exactly the same size. If you want to highlight that up, that's exactly what it meant when we were talking about angles. That's exactly what it meant when we were talking about line segments. Congruent polygons have the same shape and exactly the same size. Here is the congruency symbol. Once again, the word congruent means the same size. It does so for congruent polygons as well, right? So when you have two congruent figures, aka polygons in this aspect, all angles and sides that match up, aka they're in the same spot, are called corresponding. That's the second time we've used that word. And by default, they are congruent. They are the same size. You do not want to use the word equal. Okay, they're equal in measure, but you don't want to use the word equal because we're not talking about angle A being the same angle as angle E. We're saying that they are the same size. So you want to say that they are congruent in this particular case. So you would say in the figure to the right, there are three congruent angles and there are three congruent sides. Angle A is congruent to E. Angle B is congruent to D. And angle C is congruent to F. Now let me put three arcs on those. Look something like that. So you would say, when naming this particular figure, you would say that triangle ABC is congruent to triangle EDF. So when you're describing corresponding polygons, whether that be congruent or similar ones, and we're going to talk about what similar polygons are in a little bit, when you're naming these, the order in which you describe them is important. So if I said triangle ABC is congruent to triangle EDF, whether you had a picture like this or not, you can know that angle A corresponds and is congruent to angle E. So go ahead, you can mark that up. And you can know that without even looking at the picture. You can know that just simply from the name. Reason being, A and E are in the same relative position in the name. They're the first letter. You could also know that angle B is congruent and corresponding to angle D. You can know that they're corresponding and congruent because they are the middle letter in the names. And I bet you see where this is going. Angle C is congruent to angle F because they are the last letter in the named conjecture there, right? Not only that, you can know that segment AC is congruent to segment ED. Hold on. It's congruent to segment EF. And you can know that just simply from the name. AC corresponds, A and C are the first and last letters of the named polygon. E and F are the first and last of the other side. You can know that line segment AB corresponds and is congruent to ED. And the last thing that you can know is that segment CB corresponds and is congruent to FD on the second triangle. So when describing the corresponding polygons, the order of the vertices must be the same with respect to how they correspond. So if I say ABC is congruent to EDF, A goes with E, B goes with D, and C goes with F. I think you probably get it by now. Okay. And when drawing, this is a practice problem, draw congruent quadrilateral ABCD, and when doing that, mark all corresponding sides and name all corresponding angles. So go ahead, pause the video, and let's see if we can do that exactly. All right, so hopefully when you drew congruent quadrilateral ABCD equal to, and corresponding to WXYZ, it should look something like this, where A goes with W, B goes with X, they correspond or congruent, Y goes with C, and Z4 goes with D. Something like that. You've marked that all of those angles and all of those sides that correspond are congruent to one another. I think that probably wraps it up.